Okay, so let's continue with our next video in our coding exercise series, and we will solve the circular array rotation. This is the easy category question, and so the hacker rank. So let's read the question. John Watson knows of an operation called the right circular rotation of an array of integer. So there is a person called John. He know the right circular operation, right circular rotation operation on an array. So basically, to rotate an array. One rotation operation moves the last element to the first position and the shifts all remaining element to the right one. Alright, so 3, 4, 5 is the actual array. If you have to rotate right, so and the only one time. So 3 will come at 4 place, 4 will come at 5 place, and 5 will come at the 3 place, right? To test Sherlock ability, so Sherlock is the another person. John knows how like this array rotate, but they want to test the Sherlock. Sherlock is the another person. Watson provides Sherlock with an array of integers. So what Watson did is he provide some kind of array to the Sherlock, and okay, Sherlock has to perform the rotation. Now he asks Sherlock, "Can you rotate this array?" All right, and he has to rotate a particular number of times. All right. So as an example, a is equal to 3, 4, 5. So Watson will tell to Sherlock, "Can you rotate it to two times?" So just to test the Sherlock ability whether he can rotate it or not. All right. So once the array is rotated, he wants to know, Watson wants to know, okay, Sherlock, can you tell me, because whether Sherlock has correctly rotated the array or not, uh, Watson will randomly ask, okay, can you tell me what's the new value at the particular index? If he tell the correct value, it means he rotated the array correctly. If did not tell the correct value, it means there is some issue while rotation, right? The same thing we need to perform. So a is equal to 3, 4, 5 is the actual array which Watson has provided to the Sherlock. K is equal to 2. So Watson told to Sherlock, you need to rotate the array two times. Queries is equal to 1 and 2. Queries means, so Watson asked the Sherlock, so once you do the rotation of two times, can you tell me what's the element at the index 1 and what is the element at the index 2? All right. So as an example, so we have the actual array 3, 4, 5. So in the 3, the index is 0, 1, 2. So this is the array which Watson gives to the Sherlock, right? And Sherlock said, can you rotate it to two times? Okay. So Sherlock did the rotation. So 3 will come. So let me take a 1 second. So what it will come? So 3 will come here, 4 will come here, and 5 will come here, right? So this is the rotation. This is the first rotation, but we he has to rotate the two times. So now 5 will come here, 3 will come here, and 4 will come here, right? So 4 will come here. So this is the rotation after two rotation because k is done. So 4, 5, 3. Now the queries is 1, 2. So Watson said to Sherlock, can you tell me, okay, what is the element at index 1? So what is the element in index 1? 5. So Sherlock has to say, okay, 5. What is the element at index 2? What is the element index 2? 3. So we have to give the output 5, 3, and we have to store the element. All right. So you could see we don't need to return the whole array. We don't need to rotate. Basically, we don't need to return the whole array. Like so, this array, this big array, right? Because maybe Sherlock just want, okay, can you tell me what is the uh, element and a of 0, right? Just one element. So if we have to just return one element, why should you consume a lot of space? Along with that, if you see the constraint is like very big, like 10 to power 5 elements. So if you are if, and k is also 10 to power 5. So if you will actual perform the rotation, let's suppose 10 to power 5, then it will be like a huge task for you, right? So basically we need to find a some way, the mathematical way. So what is the mathematical way? Let me remove it. Okay. So now if you see, we have to rotate the element at two times, right? So two times means whatever the element at zeroth index, it will it will it will shift two times. So it will go to the second location. You could see 3 is now at the location 2. Whatever the element at here, it will also move two times. So one is here and one is again here, but this is out of index. But anyhow, just ignore the out of index for the time being. And whatever the element at second index, so it will also move two times because we have to rotate right, or you can say we have to shift two times right. So it will come here and then will here, but this is out of index. So but it is a circular rotation, so we have to like move it back to here, right? So if I have to just to tell you, okay, just ignore for the time being, just ignore whether it is out of index or not. If I just tell you, can you tell me the new index? Can you tell me the new index? So what your formula? New index after rotation is equal to whatever the old index plus k. Whatever the old index plus k. K means the number of rotation. So let's suppose old index is 0. Old index is 0. So what will be the new index where the 3 will come? So 3 will come after 2 rotation at index 2. So 0 plus 3, 2, right? And 4. So old index is 1. What will be the new index? So 1 plus 2, 3. But 3 is out of like index, right? But if you just do old index, that is 1, and plus 2, that is the rotation, then it will become 3. Because if you do rotation 1 here, it is fine. But in the next rotation, it will go out of index, right? Because there is no element here. It will go out of index. So what you have to do is you will do the mode. You will do the mode operation, because whenever there is circular thing, we will like do the mode. So mode will basically actually tell you, okay, where exactly the element will come after the rotation. So 4 will come here, one rotation, and then the second rotation it will come here. So it will come here. So it at index 1. So 1 plus 2, 3, and 3 modulus 3. So remainder is 0. So it will become at the 0. Now 5. So after 2 rotation, what will be the new index for 5? So current index is 2. After 2 rotation, 2 plus 2, 4. But 4 is out of index. Then you should do the mode. So 4 modulus 3, because you have to fit within the array of 3. So 4 modulus 3. Uh, Basically take a remainder. So the answer will be 1. So the new index will be 1. So this is the now you have the this formula, like new index old index plus k divided by like modulus n. If you have the new, if you know this formula, if you able to figure it out this formula, then 90% of the problem is solved. Now new index, we have to calculate. Okay, so new index is given, uh, not the new index. Now we have the formula, right? Now we have the formula, but we are actually not doing the rotation. You can ignore these two boxes now. You can ignore these two boxes now. These boxes will be helpful only when you are actually doing the rotation. Actually doing the rotation means like when you actually updating the a, which when you actually updating the like a array in like. But we are not updating the actual array, because if you update the actual array, then this question is like easy. But maybe you will get the out of memory issue, or maybe time error or something like that, time complexity issue. Because if you just update the a, your final a will be this. And now what you have to tell, okay, array a of 1, you will directly calculate, okay, a of 1 is 5, you will append to a result array. A of 2 is 3, you will directly append to that. So you are going to return that array. But you are not actually like updating the a array, right? This is just to understand. I draw this figure just to understand how I can get this formula. So you are not actually updating this array. Now now we have to tell, okay, what is a of, but after two rotation, which element is at the index 1? So if I just tell from this array a of 1, a of 1 is 5, but this is wrong. A of 2 is 5, sorry, a of 1 is 4, which is wrong. A of 2 is 5, which is also wrong, because answer should be 5 and 3. All right. So, and I have only this array. I have only this array. So I have to figure it out, the old index and the new index relation. So I know the new index and the old index relation. So for the time being, just forget modulus n. So new index is equal to old index plus k. Now, if you find the old index, because we have to know, because we know 5 will come here. All right. Because we know 5 will come here. All right. We know 5 will come here, but Sherlock also know, but we have to tell from which location 5 will come, because we have actual this array. All right. So if we know 5 come from this location, 5 come from this location, then I can directly do a of 2, something like that, right? So you have to do some mapping between the old index and the new index, which we already done, using this formula. All right. So which we are, let me clear the screen, which we already done using this formula. So new index is equal to old index plus k. Just forget about the modulus operator for the time being, because modulus is just we are adding to fit within the range, right? Now, new index basically like these indexes, like which we have to figure it out. So because if someone asks, okay, what is that a of 1? So he is asking basically a of 1, this one, like basically the new index, or you can say the new element position, right? Old index is equal to new index minus k, because you have the old index and person is asking the new index. So you have the new index in place 1, and minus k means 2. So you can get the old index. So as an example, if someone asks me, because I am not doing the actual rotation, right? Because if you will perform the actual rotation, then it will become out of memory because of 10 to power 5. So I have to figure it out, uh, some kind of relation, which we already figured it out using this formula. Now, now I have to tell the element, which element at 1 5. But if I know, okay, 5 is coming from which element, which place? Okay, 5 is coming from two place. uh, 3 is coming from which place? 0 place. 4 is coming from which place? 1 place. If I know this kind of a mapping, then it will be easy. So basically I have to figure it out the old index. So old index is equal to new index what has been asked. So 1 minus k means rotation 2. So will be minus 1, but there is no minus 1. Even you will do modulus n means 3, because generally we will do mod n when it is out of array, but minus 1 is nothing like that, right? So minus 1 is nothing. So what you have to do is you have to add the n. If you add the n means 3. So 3, forget, because in the Python you can't perform the modulus operation of the negative number. So 3 minus 1, 2. So 2 divided by 3, or modulus 3. So answer will be 2. Now you know the old index. You know the old index too, because I have to figure it out, this mapping. Someone has asked me this index, right? So I know, okay, from some location it will come, but from which location I have to figure it out. So I know from 2 it will come. I know from it 2 will come. So what I will do, a of 2 is 5. I know a of 2 is 5. So it means a, whatever the ask is a of 1, that is also the 5 in the new rotations. That is the same thing we have to perform. Even you can try for the uh, one second, even you try for the other one. So old index. So old index, what has been asked? 2, 2 has been asked, right? And minus 2. minus 2. So 2 minus 2 is equal to 0, 0. Now you have to add the 3 and then modulus 3. So answer will be 0. So we have to basically actually calculate the a of 0. So a of 0 is 3. Answer is 3. Right. So answer is 3. Okay, let's figure it out. So how to write the code? So we need the result array, right? And query is a array. So we have to tell all the elements. So for q in queries. Okay, now you have the formula. So what is your formula? Old index. You have to find the old index. Old index is equal to new index. New index means query minus k, right? But we have to add plus n because why we have to add the plus n? Because modulus will not work on the negative numbers, and we have to take the modulus so that it will fit. Now you will just do result dot append array of old index and then return result array. That's it. And if you try to run the code, sample test case has been passed. Let's try to submit the code. So all the test case has been passed. So that's the solution. It's easy. It's not very difficult because I believe uh, this thing everyone can able to figure it out. And if this thing everyone can able to figure it out, then we know, okay, we have to kind sum of mapping between old index and new index. So you can just shift the k here and the mode here. Now maybe you have one question. Okay, if there is a divide operation this side and if it will go on the another side, it will become multiply. Then what will happen? The mode, so mode operator will remain same. So if mode is here, then the mode will also will remain here. So mode here. So old index, a new index minus k mode n, and we are adding plus n because modulus operator will not work on the negative number. So that's it. That's the end of the video, and thank you. You can also try this question. Okay. So let me stop this.